All right, let's talk about some actual circuits. Yay.
Hang on, I'm trying to invite a friend too.
You're trying-
We're in the middle of a golf game. We're in the middle of a golf game on hole 4, right?
Let me know when you're done.
Alright.
I'll wait.
We're trying to figure out
All
how to
right,
get out of
so we'll talk about a series circuit, and we'll do it in black. A series.
I'm trying to tell them how much power I got on my
Series circuit. All right, so what are the requirements for a series circuit?
First, it needs to be in series.
Well, if I want to build a series circuit, I need a couple of things. Okay, battery. We'll call that a power source. What else?
Conductor.
Okay, conductors.
Load.
Okay, resistors or a load. We'll say a load. Resistors act as a load. And what else? Ready to help you out?
Well, there's an optional thing with the switch.
Okay. No, I don't need a switch.
Okay, so that's an option.
Okay, there is
Lead.
power source. There's a load,
Lead.
and there's and there's a conductor.
Continuous loop between
Continuous
the
loop.
power source.
All right, one and then one path. I'll put this and only one path for current. One path and only one path. So there we go. So I've got a conductor coming around to a load. Do I have a series circuit yet?
No, you need to connect it to the other side.
Nope, I need to connect it. So once it's on. How about now? Do I have a series circuit? What do I have here?
Switch.
Open
Or
circuit.
break.
I have an open. It means it's off. So there. Now we connect it. Now we have current flowing. One path and only one path. All right. So that is a series circuit. Well, let's talk about a few other things here. I've mentioned some words here. What is voltage?
Electrical potential.
All right. I often say it's electrical potential. So should we use the bathroom sink analogy?
Yeah, sure.
All right, so you go to the, sure, you know what that is. So voltage is the potential, the ability to push. So if you were to go to the bathroom sink, it's the voltage is like pressure. It's what pushes the water out. It's how fast the water, the high voltage will push the water out. We have amperage. Amperage is the actual flow of electrons. Oops. And that is like the actual water coming out of the faucet. You could measure that. Flow of electrons and resistance. Resistance is the opposition to the flow of electricity. All right, so if we have these in mind, this is all 309 stuff, right? We covered all of this. We learned all about this. So I don't want to spend a bunch of time here on it. Well, let's talk about Ohm's law. Ohm's law. So there's this guy named Ohm. And Ohm says that I don't like where my notes are. They're like all over the freaking place. One volt will cause 1 amp to flow through 1 ohm. And that can be expressed as the expression E, I, and R. We're going to cover that a little bit more. Where if I say, if I don't know, well, we'll do that in a little bit. Then we have Kirchhoff's laws. And this is where we're going to spend a lot of time. So,
If I could find, what is that?
Yeah.
Flow through one what?
1 amp. Oh, flow through 1 ohm. Yeah. Ohm squiggly. Oh, 1 Lululemon.
There you go.
One expensive junk pants.
Yes. All right. So the laws that we need to work with when we deal with series circuits, again, everything we covered in 309. Voltage. So if I voltage, which is also electrical pressure, which is also pressure or potential. Thank you. Voltage is total voltage in a circuit is the sum. Sum is plus, minus, multiplication, or plus. Okay, is the sum of the voltage drop across all resistors. All right, that's another way of saying that if I have a battery, some sort of load, I'll just put the little ground there. I've got resistor, and a resistor, and a resistor, and there. Do I have a complete circuit?
Yes.
Ooh, I hear a no.
Yes, you do.
Oh.
I do, because wherever you see these little ground symbols, that means there's a path, I'm just not showing it, that goes all the way back around. Now maybe this, if it's in an airplane, it's just a big wire that's bolted to the aluminum frame here, and this wire is bolted to the aluminum frame over here. And so the electricity flows through this little ground, through the aluminum in the aircraft, find its way back up and around. All right, so it's there. So do I have a path here and I got everything running? Okay, so Kirchhoff says total voltage in a circuit is the sum of all voltage drops across all resistors. Well, if I had a 6-volt battery and I were to measure the voltmeter across each resistor,
Be 2 volts. They were equal.
and if all of these were equal, they were all equal, then this would be 2 volts, this would be 2 volts, and this would be 2 volts. So 2, 4, 6. So the sum of the voltage drops across all will equal this. And that's assuming they're all equal. And of course, these don't have to be equal. I can make them different sizes. This could be
1.
this could be 1.
Three.
This could be 3, and then this would be,
Ow, the knee stumper.
well, it's already 2, right? 4, that'd be 2. So it's whatever the size of the resistors. They're going to be dependent upon the voltage drop. But it says that you add up the voltages to equal 6. All right? So the way I would write that as a formula is R total equals, and this is resistor 1, this is resistor 2, this is resistor 3, would be R total equals,
You got them all
yeah, R1. What am I talking about? Voltage. Then I went off on resistors. I'm sorry. Hang on.
What the hell are you doing?
I don't know, man. It's been one of those days for me. All right.
Total.
Voltage total. Voltage total. And here's the funny thing, because sometimes we write it V and sometimes it's E. So up here it's like E, I, and R, and down here it's V. So they go figure, but it's the same thing, right? So voltage total equals the voltage of R1 plus the voltage of R2 plus the voltage of R3, on and on and on. If I had R4, we put that in there, and so on and so forth. All right.
Schematics, do you care if it's V or E?
We go with the convention E.
Okay. Because the computer program is all V.
All right. Then if we talk about current. In a series circuit, because when we're talking about series, the current is the same throughout the circuit. So if we look back up at the circuit we just drew here, and we can look at voltage as pressure. So we lose a little bit of pressure across R1, we lose a little bit of pressure across 2, we lose a little pressure across 3, right? Lose a little potential. If we add up how much we lose across each one, it equals the total. That should make sense. But if we look at the current is actual flow. And so if this was a pipe with some water, isn't the same amount flowing through R1, the same amount flowing through R2, is the same amount flowing through R3? So whatever I put in and start to flow right here, where's it going to go? Well, it doesn't go anywhere. It's got to come out the same. So whatever you put in, it's going to come out the same. So the flow is the same through the whole thing. So therefore the current is the same through the entire circuit. So if I had an ammeter and I put it right here, because ammeters are supposed to be put in series, and if I put it right here in series, and I put an ammeter here in series, that ammeter is going to read the same thing every which way, because the flow is the same in the beginning as it is in the middle as it is in the end. No matter how many resistors I add, the flow wherever it is on the start is going to be the same as it is in finish, and the same in the middle. So if I want to write that, I would write I. What is V stands for what? Voltage. What does the E stand for? Where did we get E? Electromotive force. I is intensity, but it's also current. So I and A are the same thing. So I total is equal to the current flow through R1, which is also equal to the current flow through R2, which is also equal to the current flow through R3, and on and on and on. And now we talk about resistance. We're using R, thankfully. So resistance, the formula is, it's the sum. Sum means what?
Total.
Doesn't mean total.
Plus.
Added,
Yeah.
right? This added is the sum of all resistors. So up here, I just add up whatever R1, 2, and 3 happen to be. Just add them all up. And the formula for that is R total equals R1 plus R2 plus R3, and so on and so on. Not real hard now, is that?
Do you have like a trick to memorize? E equals V, I equals C, R equals R? Or you just have to memorize it?
You just have to remember it. It'll come to you real easy. Okay, so keeping these things in mind, we can start to dissect and look at circuits and figure them out. So if I were to draw a circuit, to get an example out so I don't blow it here. Let's see. Oops, we'll put a resistor over here. Down here, put one right here. All right. So when, I don't have a ruler here, but this is how I want you to do all of your circuits. So somewhere near where the resistor is, please write this. We'll do this one here. I-R-P. All right, so these are the totals. I total, power total. This is 1. This is 2. This is 3. All right, if I gave you some certain, make it in red, your givens, some certain values, said, oh, I got a 12-volt battery, and I've got 2 ohms of resistance, and we'll make this one 2 ohms, and we'll make this one over here 4 ohms. If I gave that to you, you should be able to compute everything I just taught you about this particular circuit using Kirchhoff's law, which was all of these right here. V total equals V1 plus V2 plus V3. I total equals the same in all, and R is the sum of everything. And using Ohm's law. Now when I do a circuit like this and I have to figure out everything about this circuit, I write somewhere right on here E, I, and R. I make a nice E.
P is millivolts or?
EIR. I'm not going to worry about P right now. And that is to say that Ohm's law, E equals I times R. And I can look at that by just covering up any one letter of this. If I cover up the E, and I have I times R. If I want to know I, what's the formula? It's E divided by R, so it's E over R. And what is the formula for R? E divided by I. All right, so that's easy enough, right? Now I also have P over here, and there are many different formulas for everything, but you know I like pi. You do now. Pi. So P equals I times E. It's just pi. I don't have a picture of it for you, but in your book you have this wheel. All right, and these are actually all of the formulas. So there's a whole bunch. You want to know P? It's P equals I times E, or P equals I squared times R, or P equals E squared divided by R. I can equal, in here I said it's E divided by R. It can also equal P divided by E, or the square root of P divided by R. Okay, it goes around the whole, and there's all these different formulas, but you know what? Everything I just gave you, you can work with. And if you know two things, you can always find the third, right? Because if you know E, you can, if you want to know E, you need I and R. If you want to know I, you need E and R. So as long as you have two things, you can always find the third. And I'm always going to work with E, I, and R, and P is going to be added later. So looking at this right here, can you fill in everything, the E, I, R, and the P, and everything on here?
Yes.
Okay, not difficult. Did it in 309, right? So what is the first thing that I can figure out with this circuit? Total resistance. Real easy. What is total resistance?
8 ohms.
It's 8 ohms. Why is it 8 ohms? Because it's this. Would you stop? Because it's this. It's like a game show over here. Ed McMahon and this over here. Yeah, I know. Okay, so it's the sum of all. So it's 4 plus 2 plus 2. So our total is 8 ohms. All right. If I know that that is 8 ohms, I now have 2 of the 3 things, right? So what else can I solve for? Current total. Current total is what? If I want to know I, it is E divided by R. So what is that? What is it? 1.5 amps. Now if I know that's 1.5 amps, how many amps are flowing through this resistor? Well, that'd be 1.5, wouldn't it, Brett?
It surely would.
How many amps are going to flow through R2?
1.5.
How many amps are going to flow through here?
1.5.
1.5. All right. Now, if I know that, and I know that, I found 2 of the 3 things. So if I found 2 of the 3 things, how can I? The third one is easy to find, right?
Yeah.
So now I just need to find E, and E is I times R. So I times R, 1.5 times 2 equals
3.
volts. And 2 times 1.5 is still 3 volts. And 4 times 1.5 would be 6 volts. Easy enough? Now, if you want to solve for pi, what's the answer? I times E. So 12 times 1.5? 18? Don't lie to me. 18 what? That's watts. Watts, okay. Then we could solve for all the rest of them here. Well, what is this?
That's 4.5 watts.
4.5 watts.
That one's the same.
4.5 watts and
9.
9 watts. Easy peasy, right?
Lemon squeezy. Let's go.
So this is what you need to be able to do on the FA tests. And you just did it. So how hard is that? Oops, guess I'm out of paper.
But waste some trees, yeah.
Well, I don't like trees, you know that. They suck up all the oxygen.
And they get in the way of the plan.
Too soon? From what? What happened? Oh, I don't like that one. That one's too easy.
Yeah, don't do that one.
The heck, that one's too easy too.
Do we get any sweet handouts for this one?
Yeah, I do have sweet handouts for this one.
Oh, I'm so excited.
Want me to bring it on?
Bring it on.
All right, since it's all review, we'll do one more of these.
That me was a good time.
All right, E-I-R, E-I-R. All right, what are my givens here? We'll do 24 volts.
I don't want to draw that many.
0.5 amps, 8 ohms, and I believe this is 15 volts. There we go. As hard as I can make it. So we'll pause while you do that. Do that. There we go. So we got E, I, and R right there. All right, so what's the first thing I can figure out here? Fill in the what?
Car.
Current, right here. The current is what? What's the rule for that? Same everywhere, so that's a gimme. 0.5 amps, 0.5 amps, 0.5 amps, all the valves. All right, now what? I can solve for almost all the totals. Well, I'm still kind of stuck over here, right? I don't have much going on over there. That one looks a little difficult. What?
Save that for last.
Save it for last. You know what? Just in the true spirit of the class, just ignore it. It's probably not important, right? And we got 1, 2, 3, 4 things here, and if we get rid of that, that's still what? 75%. That's a C. So that's fine, right?
Yeah, that's fast.
I know. That's right. Okay. So what is my total resistance here? 48. Okay, 48. And make sure you put your symbols, because on the test, if you don't put a symbol, I'm going to go 48 what? And you get it wrong. So right here, we got 30 ohms. Here we've got 4 volts. 4 volts. All right. Now we're over here. How are we going to do this one? We only got 2.
Well, if your total's
Well,
48,
if
you
we
try
do
the other two, and
15
you'll be less
You can do a couple of
All right. So I hear Brett over here. So all I have to do is subtract 15 and 4. And 24, whatever's left is that's it. So 24 minus 15 minus 4 equals 5? 5 volts. All right, so we check that. 15 plus 5 is 20, plus 4, 24. Ooh, that looks good. All right, so now we can just do simple math right here. And we end up with 5 times half is 10 what?
Just 10.
Just 10. 10 Lululemons. All right.
That's
Now, this is the spot where you've got to ask yourself. I'm not going to ask you. Did you understand this? If you did it and you're like, all right, I hope this doesn't come up again. It will, over and over and over and over.
I bet we'll see it Friday.
And every week from here on out. And not to be unkind, but it does say in several places in your lab sheets, you get to a spot and it says right down there, if you don't understand this at this point, you start the project over, or you will go to project 1. All right, so it's,
Shoots and ladders?
yeah, we'll stop this and then you can do another practice one. All right, so we just hit a snag. So let's talk about this. We'll make it real simple. If I have one resistor, and I have no idea what it is, and I don't have the ability to actually put an ohm meter across it, but this is 6 volts.
That's gonna be 6 volts.
It's going to be 6 volts. That is not the example I want to use because this made it too easy and it doesn't work out. All right, let's see.
Add another resistor.
That's what I'm going to do. Add another resistor. All right, and this resistor can. Well, hang on. Let's do that. Let's talk about the resistance of the wire, just like I was talking about. Okay, so I want to know what the resistance of this wire is, and so with no power on it whatsoever, I take an ohm meter. All right, no power, so we got to make sure we have no power. So no power, and I put an ohm meter across it, and I say, all right, what is the resistance of this wire? No, and I'll just add it to this one over here. And what is the resistance of this wire? And with no power on at all, with the Simpson meter, I basically show it's 0. I mean, it's I zero out my meter, not infinite. Infinite's open. So I say, oh, it's like 0 ohms. I can't really read anything. It's like 0.0000 something. God, it just looks like 0 to me. I'm going to call it 0. It's 0 ohms. All right? And say, okay, that's fine. Let's just give this some value right here. So we'll say that's 6. And this right here is, we'll just say it's 4 ohms. All right, so 4 ohms. And I actually plug this circuit in and I try and run it. And so I've calculated it out that this is 6 and that's 4. And calculating it using a calculator, what should the answers be right here? What's right here? 6. This is not hard. 6 volts. How many? 4. And what's my current flow?
1.5.
What is it? 1.5 amps. Okay. And I've calculated it, and that's what I got. I'm going to use red here. But I measure it. Now I measure it. And I measure it, and I'm like, well, that's kind of funny. I'm getting like 5 volts here. Well, you know what? Let's not even worry about that. Let's go back here. Remember my question? I said, what is the resistance of this wire? So how can I determine the resistance of the wire? A minute ago I said it was 0. What happens if I take and I do this, and I put a voltmeter, and voltmeter says 0.5 volts. I put a voltmeter here, it says 0.5 volts.
Uh-oh.
Well, what is the resistance of the wire?
1 volt. Total.
That's total.
1 volt.
About that.
0.5 divided by 1.
It's Ohm's law.
3.
EIR. If I have 0.5 of a voltage drop and I have 1.5 amps of current, what is the resistance of the wire?
0.3 ohms.
Is it 0.3? 0.3 ohms. Ohm's law. You guys follow or did I lose everybody?
That's obvious.
I don't understand like what you were trying to lead up to.
How do you physically check it?
Okay, what I'm leading up to is exactly what happens in lab. I will say, what is the resistance of that piece of wire? And you'll put it up to your ohm meter and go, it's 0. Are you sure it's 0? Put it in. When you're working with these batteries, you're going to be having 10, 15 amp draws. So I think it's something like 10 amps. You have 10 amps working. Well, at 10 amps, things start to multiply out. And you start to see effects that you didn't see before. So yeah, maybe you really have very little, a negligible effect with your wires when you're working with your little tiny batteries. When you get big batteries, you get big effects, but you can't see it with your ohm meter. So you put your ohm meter across the wire and you say, hey, Kevin, how many ohms you got there, Brett?
She don't work no more.
Yeah, I don't know how many ohms because I actually tried to measure amps within the voltage. You take a wire and you put it in your ohm meter and you check the ohms on this piece of wire and the ohm meter says what?
0.
0. Or you say, Hell, it's practically zero. The needle barely moved a tiny bit. Let's call it nothing. Well, is it nothing?
Nope.
No, it's something is there. And
Digital.
the more power you put through this wire, the more resistance you're going to start to notice. So in one respect, when you're only putting a little tiny bit of voltage through at the ohm meter, you really see very negligible resistance. But when you put 10, 15, 20 amps through something, the resistance suddenly shows up in these wires. Well, how can you measure that? I know, hook it up to the battery and just hook the ohm meter up while turning, right?
Give it a shot.
If you're going to do that, call me, let me know. So I had a conversation with Tom. He stops and, whoa, you're going to blow up the meter. I'm like, Tom, let him do it. So, all right, so
It takes Tom 20 minutes to try to explain.
I'm going to go back to this. So let's do something. So here we have a big 12 volt battery, and we've got 10 amps flowing through this thing.
Damn.
Is that all right?
Amps kill.
Well, it's a combination of the two. And you have a load, and let's say the load is 1 ohm. Oh, I can't do that because I just made up a voltage in an amp, and then I made up. So how many amps would I have, or how many? 1 ohm. That's right. So does that work out? No, it doesn't. Can't do that. What's my total resistance? 2?
1.2.
1.2. There we go. So 1.2, and I calculate this. I use a calculator. And say if I have a 12 volt battery and if I have 1.2 ohms, then I must have what kind of current flow? 10 amps. Okay. I build the circuit. I put an ammeter in here, and I only get 8 amps. What happened? So-
resisting. Get a bigger gauge wire.
So just like you guys are doing in lab, you do one where it's calculated, one where it's measured. So now I do one where it's measured, and I said, oh,
Shows a little different.
EIR. Well, I do have 12, that worked out, but I only have 8 amps. And when I measured this over here with my ohm meter, it did measure out at 1.2 ohms. So what happened? Why did it go from 10 to 8? And how come this math no longer works out?
It's not calculated. It's
What's
not
that?
perfect.
Huh?
It's not perfect.
No. This is real. This is really happening. And I'm giving you guys way heads up I don't normally do. What happened here that, is there more resistance somewhere? There's more resistance. Where's this resistance?
The wire.
On the wire. So I say, whoa, take it apart. What's the resistance on the wire? I don't say take it apart. What's the resistance on the wire? You say, hang on, let me check. And you take it all apart and you measure it with an ohm meter and you say, the resistance is? Zero. I don't understand. I say, well, it's not called Ohm's suggestion. It's called?
Ohm's law.
Ohm's law. So while this is working, I take another voltmeter and I put it from here to here. And I take a reading, and oh, I'm getting a voltage drop of, and I don't know how the math is, let's say I'm getting a voltage drop of some number. You get a voltage drop of some number. The math isn't going to work out entirely, but I get a voltage drop of 2 volts. Oh. 2.4. And so how many ohms do I have? How many ohms is it?
Make me turn my calculator.
EIR, I want to R, so it's E to,
0.25.
what's that?
0.25.
0.25. Do you think you were able to read 0.25 amps on ohms, 0.25 ohms on your Simpson?
No.
Hell no.
See, that's what I'm talking about, but how much was there?
0.25.
0.25, and it caused you to lose how many volts? 2. And so it dropped your amperage down. See what I'm saying? You can figure this out. You can figure out the resistance of anything that's unknown by measuring the voltage drop. So rather than, hey, what's the resistance of that? Well, hang on. Let me take the whole airplane apart and measure that. I just turn it on and do a voltage drop. Okay? Perfect example. I'll give you one more. This is something maybe you can relate to. Maybe not. You have a car. You have a car battery. And if I'm looking at the car battery down, it's a car battery. It has a post on it, right?
Threaded or auto?
Old school auto.
2 steps.
2 studs where you had the clamp on there. All right? Remember the old clamp style?
Yep.
Okay. So here's the post sticking up. And then what'd you have around it? The wire comes in, and then you have this clamp that goes around it.
You got bolt.
It's stripped out probably.
Yeah, yeah, that's stripped out.
Holy strip.
All right, this is terrible. So you got the bolt. Okay. What is the resistance? Okay, and so you go to start your car.
Okay.
Click, click, click. Okay.
Hit the starter.
Do you have a bad battery, a bad alternator, or something else?
I'll call the clutch and figure it out later.
There you go. Okay. So, well, so you YouTube it because you're a YouTube mechanic.
Certified.
And certified YouTube mechanic. And somebody says, well, sometimes you get a little corrosion between this post and this clamp, and it prevents electricity from flowing through there.
You gotta paint that red stuff quick.
And so you're like, I'm a smart guy, gal. I'm in my 2nd week of electricity. I know that all I have to do is take an ohm meter and go from right here to right here. So ohm meter from here to here, because there should be no resistance between these two, right? Am I correct on this? You don't know. Should there be resistance between this clamp and that?
No.
No. And can you see that where I put the little red right here? How maybe I have to roll up a little bit so you can see it. So and I look at it and I'm like, what the hell is that? But I told you what it is. So it's a battery. So this blue clamp is on the post. Should there be any resistance between the two? No, but I've got some red stuff growing there. That's, I don't know, some sort of algae. Red algae is growing. Okay, it's corrosion. So that corrosion is causing a problem, isn't it?
Yeah.
So you take an ohm meter and you go between the two. What should you see? 0. Oh, there should be no resistance. And you do that. And there shows, needle barely, it's like something, but hardly anything, right? Huh, is that the problem? We'll try this. Take off the ohm meter and put a voltmeter here. Now I say to Brett, I'm going to hold this voltmeter right here between here and here. And of course this is connected. That'll be the positive, this will be the negative. And this is connected to the car. And what should the voltage between those two things be if there's no resistance?
0.
Right, so because EIR, if there is 0 resistance, there should be
0.
no matter what the amperage is.
Yeah.
Okay. And I do that, and I show 0. But then I say, Brett, hit the starter. Starter's going to draw, let's say it draws 100 amps. And turn the lights on too.
Now I gotta get the subs going.
100 amps. And I get a 4-volt drop across there. Is that something I wanted to see? That is not. That is, what is my resistance? EIR. What is my resistance?
0.04.
0.04 ohms?
Yes.
Could I see that on the ohm meter? Nope. Did it have a huge effect?
Yeah.
I lost 4 out of 14 volts. That could be enough to be your problem right there. So you see what I'm saying? Sometimes the best way to measure ohms is with the voltmeter and do the math. Did you do that today, MJ?
I did do that today, yeah.
Yeah, one of the projects you had to do that, huh?
Yeah.
You have a resistance that you can't determine. Undeterminable resistance with an ohm meter.
I asked you how to do it, and you were like, "We gotta think about it. It's a mind bender."
Well, it's kind of explained it a little bit here, but once you do it, it's like, get used to that. This is Ohm's law. This is the projects where at some point I'm going to say, hey, if you can't figure this out, we need to go back to the beginning. All right. Chutes and ladders. It's like that's a chute, isn't it not?
Candyland.